So here in our solution, we have given function x which is equal to square root of a into sine inverse of t. X is equal to square root of a into sine inverse of t, and y which is equal to square root of a into cos inverse of t. Okay, cos inverse of t here is a into sine inverse of t. Sine inverse of t is the part of their numerator. Okay, a part of their exponent here. Okay, let me write this one again. We have given sine inverse of t, it is a completely power of a constant term a. Okay, so x can be written as, so it is already given, a to the power sine inverse of t, and the term of y we have here, y which is equal to a to the power cos inverse of t here. Okay, cos inverse of t, and then we want the value for dy by dx here. Okay, we want the value for dy by dx. So see that we have the term x which associated with the term t, and y it is also with the term t. Okay, so if we are going to differentiate with respect to x and y, obviously these are the constant term, always gives us the value 0. But what we know so far, we can apply parametric rule for differentiation or parametric differentiation as dy by dx which is equal to dy by dt upon dx upon dt here. Okay, so we can apply this parametric type of the differentiation for finding the value of dy by dx. Okay, now let's apply the parametric differentiation. That means we have to find out the dy by dt first, then we have to find out the dx by dt first second, and then take the reciprocal. Okay, so x which is equal to a to the power sine inverse of t. Okay, a to the power sine inverse of t. This one is the value for x which is equal to a to the power sine inverse of t. Okay, yes, and we want the value for dx by dt, as we have denominator dx by dt. So find out the dx by dt here. So dx by dt means we have to differentiate our square root with respect to d by dt here. Okay, d by dt of square root of a to the power sine inverse of t here. Okay, this is a d by dt of square root of a to the power sine inverse of t. Okay, we know that root of x having differentiation 1 upon 2 times root of x. Okay, that means we write their differentiation as 1 upon 2 times square root of a to the power sine inverse of t. A to the power sine inverse of t. Okay, then after that we have to differentiate d by dt of a to the power sine inverse of t. A to the power sine inverse of t here. Okay, so let's go for finding next differentiation. First step, keep as it is. First part, keep as it is. Differentiation of a to the power sine inverse of t. Okay, this one is a to the power sine inverse of t here. This one is a to the power sine inverse of t, and we know that differentiation of a to the power x is a differentiation of a to the power sine inverse of t. That means it is a completely constant term. We have to differentiate a first. Okay, and the differentiation of a to the power x as a to the power x into log a. That means a to the power x, it remain a to the power x. Then we have to differentiate a to the power x as a to the power x into log of a here. Okay, so here a to the power x step keep as it is and differentiate it further. Okay, that means a to the power x having differentiation a to the power x as it is, a to the power sine inverse of t as it is, and differentiation of, after that a to the power x having differentiation a to the power x log of a, and after that differentiation of a sine inverse of t. Okay, d by dt of sine inverse of t. I am writing all these steps separately. Okay, so it is a composite type of the differentiation. We have to differentiate sine till the last function available in our example. Okay, so that's why differentiation of sine inverse of t after here. Let's go for finding the next value. First 1 upon 2 times square root of a to the power sine inverse of t as it is. Okay, keep as it is this term. Okay, as we don't have to change anything there. A to the power sine inverse of t into log a to the power sine inverse of t into multiplied by log of a, completely multiplied by log a, and which multiplied by sine inverse of x. What is the differentiation of sine inverse of x? Which is 1 upon square root of 1 minus x square. Apply it here. So which is 1 upon square root of 1 minus t square. Okay, sine inverse of t, that means 1 upon square root of 1 minus t square. Okay, so write down all these terms together. dx by dt, I got the value a to the power sine inverse of t, a to the power sine inverse of t. Let me write good power. A to the power sine inverse of t, a to the power sine inverse of t upon 2 times square root of a to the power sine inverse of t. Okay, this one is complete bracket. Okay, multiplied by log of a divided by square root of 1 minus t square. Keep as it is. Okay, similarly find out the value for dy by dt as I have done for dx by dt. For dy by dt, that means we have to differentiate our function y with respect to t. That means a to the power cos inverse of t, differentiate similar like this. Root x having differentiation 1 upon 2 times root x, that means a to the power cos inverse of t here. Okay, a to the power cos inverse of t. Okay, after that differentiation of a to the power x as a to the power x log a, that means a to the power sine inverse of t, a to the power sine inverse of t into log a. Okay, and completely divided by differentiation of a cos inverse of t. Okay, let me write this one again. This one is a to the power cos inverse of t. Okay, a to the power x having differentiation a to the power x into log a, that concept I applied here. Okay, so a to the power cos inverse of t into log a divided by differentiation of a cos inverse of t with respect to t, which is a minus 1 upon square root of 1 minus x square. Okay, that means which is a minus 1. So we write minus 1 here multiplied by minus 1 upon square root of 1 minus t square. This one is the our dy by dt here. So next step we write here dy by t as, okay, a to the power cos inverse of t, a to the power cos inverse of t. Let me write it again. A to the power cos inverse of a to the power cos inverse of t. Okay, a to the power cos inverse of t multiplied by minus log of a. Okay, upon, to keep as it is, a to the power cos inverse of t. Okay, so this one is the bracket complete here. Okay, minus 1 a to the power cos inverse of t. Okay, this divided by this multiplied by minus log of a divided by square root of 1 minus t square. Okay, this one is our next step. Now we want the dy by dx here, that means dy by dt upon dx by dt. Substitute these values here. So substitute here dy by dt. What is the value for dy by dt? A cos inverse of t upon 2 into a cos inverse of t. Okay, so can it let me write here a cos to the power cos inverse of t. Okay, a to the power cos inverse of t divided by 2 times square root of a to the power cos inverse of t. Okay, yes, and completely divided by, this is a dy by dt, completely divided by dx by dt. We have to use dx by dt from here. A to the power sine inverse of t, a to the power sine inverse of t completely divided by 2 into square root of a to the power sine inverse of t. Okay. Okay, this one is the this term divided by this term. Now again this term divided by this term. So as we seen that both are the similar term, expect that negative sign. Okay, take that negative sign and cancel this one. So we left here the value with the negative of 1 here. Okay, so this one is the next step, negative of 1 multiplied here. Okay, we can see here that 2 cancelled with this 2. Okay, so a to the power cos inverse of t divided by 2 times square root of a to the power cos inverse of t, and similarly a to the power sine inverse of t. Okay, substitute the values here. So a to the power cos inverse of t. Okay, if we take the square from both sides, we get the y square as a to the power cos inverse of t. So we write y square divided by a to the power cos inverse of t. We know that it is the term y. Okay, completely divided by a to the power sine inverse of t, a to the power sine inverse of t, which is a x. Okay, a to the power sine inverse of t, which gives us the value x square. Okay, as we have a to the power sine inverse of t, that means the square for both of the side. A to the power sine inverse of t square, square root cancel, the left term here x square. Okay, the value x square here divided by a to the power cos inverse of t, a to the power cos inverse of t, we have the value x here. Okay, we substitute the value here y square by y, and completely divided by a to the power sine inverse of t into square root of a to the power sine inverse of t, which is x here. Cancel this x with this x, y with y. So we left here the value with the y upon x. Okay, so our required dy by dx we found here y upon x, but minus 1 still multiplicand here. Okay, so which is a minus 1 here also. So dy by dx, which is a minus 1 multiplied by y by x. Okay, so we directly write it as the y minus of y divided by x as the differentiation of y with respect to x, which is given in our option number first. Okay, so our option first, which is true here. So I hope you all have understood this solution. These are the little bit calculation, quite confusing, but if you follow the proper way of the solution, proper steps, you will get the right answer. Okay, let's move for the next example. Yes, in our next example, we have given y of x, which is equal to cot inverse of under bracket 1 plus sin x, okay, and plus square root of 1 minus sin x upon square root of 1 plus sin x minus square root of 1 minus sin x. Okay, and x belongs to interval pi by 2 and pi. Okay, then we have to find out the value for dy by dx at x, which is equal to 5 pi by 6 here. Okay, so we have inverse trigonometric term given. Try to simplify it first. So y of x, which is given in the form of cot inverse of some terms given here. Okay, so first of all, we are going to simplify our given term, and then we go for the final answer. So as we know that square root of 1 plus sin x can be written as square root of 1 plus sin x. Square root of 1 plus sin x can be written as modulus of sin x by 2 plus cos x by 2. Okay, or cos x by 2 plus sin x by 2. So we write it as the cos of x by 2 plus sin of x divided by 2, which is the square root of 1 plus sin x. Okay, next square root of 1 minus sin x. Square root of 1 minus sin x can be written as cos of x by 2 minus sin of x by 2. Okay, square root of 1 minus sin x, we write it as the square root of 1 minus sin x as a cos x by 2 minus sin x by 2. The only positive negative difference it is there. Okay, when we get the negative under square root, take the term there as a negative, and when we have the positive term under square root, take their value as a positive here. Okay, yes, we have all these value. Let's go for the substitution of the values here. Okay, y of x, then y of x we can write here. Let's go for the next step. So y of x can be written as cot inverse of square root of 1 plus sin x. Square root of 1 plus sin x, which is a cos x by 2 plus sin x by 2, modulus of cos x by 2 plus sin x by 2. Okay, cos x by 2 plus sin x by 2 plus Next step, square root of 1 minus sin x, which is a cos x by 2 minus sin x by 2. Cos x by 2 minus sin x by 2, okay. Cos x by 2 minus sin x by 2 here. Yes, this one is the next step. Completely divided by, we have next step, square root of 1 plus sin x, okay. 1 plus sin x can be written as cos x by 2 plus sin x by 2 again. Again minus sign as it is under modulus, cos x by 2 minus sin x by 2 here, okay. As we have interval which given pi by 2 to pi, so we have restricted, with some of the interval. So using our theta from pi by 2 to pi, find out their modulus, okay. So modulus completely depend on our theta, okay. So next step we write it as the cot inverse of, remove their modulus. So we left here the value. Again, so we cos x by 2 can be written as cos x by 2 as it is here, plus sin x by 2, their modulus it remains same, okay. Under the interval pi by 2 to pi by 2 to pi, okay, we write a cos x by 2 as a minus cos x by 2 and a sin x by 2 as a plus sin x by 2. This one is our numerator, okay. This one is the numerator. Let me write this one again. This one is the round bracket here, okay. This one is also round bracket and completely divided by, okay. Again, let's go for the expansion of this modulus again. So cos x by 2 plus sin x by 2 keep as it is, cos x by 2 plus sin x by 2. Positive term always remain positive, but when it comes to the negative term, positive goes to negative, negative goes to positive, okay. Now see that we have negative of negative cos x by 2, we write it as the positive cos x by 2. Again negative sin x by 2 and that negative, so it gives us the minus sin x by 2, okay. Yes, we can see that positive cos negative cos x by 2, positive cos x by 2, positive sin x by 2, negative sin x by 2 cancelled, okay. Then next step we write here cot inverse of sin x by 2 plus sin x by 2, that means 2 times sin x by 2, okay. Total divided by cos x by 2 plus cos x by 2, 2 times cos x by 2 here, okay. 2 times sin x by 2 divided by 2 times cos x by 2. 2 cancel here. Then we write cot inverse of sin x by 2 upon cos x by 2, which is a tan of x by 2 here. Cot inverse of a tan x by 2. And we write a tan x by 2 plus, okay. So we have to expand tan x by 2 in the form of a cot inverse, okay. So we can convert this term step as a cot inverse of tan, okay, cot inverse of a tan. Then we can easily write their values, okay. So we know that cot inverse of a theta plus a tan inverse of a theta, okay. So cot inverse of a theta plus tan inverse of a theta, as earlier we have learned here, okay, in my previous example. Where is this example? Yeah. So we have learned here tan inverse of a theta plus cot inverse of a theta, which gives us the value pi by 2. So apply same inverse trigonometric result in this example, okay. So cot inverse of a theta plus tan inverse of a theta, which is the pi by 2. Cot inverse of theta plus tan inverse of theta is a pi by 2. So we have cot inverse of a theta. So we write a cot inverse of a theta as a pi by 2 minus tan inverse of a theta, okay. Pi by 2 minus tan inverse of a theta. So we write pi by 2 minus tan inverse of a theta. Now instead of a theta, we are taking a tan x by 2, okay. So tan inverse of tan x by 2 here, okay. Tan inverse of a tan x by 2. We know that tan inverse of a tan, it goes to the own term only. So we write here a pi by 2 minus x by 2 here. Pi by 2 minus x by 2. This one is the value for y of x, okay. This one is the simplified form for our given y of x, okay. This one is the y of x given in our example. I written this y of x as a pi by 2 minus x by 2, which is equal to y of x. Okay. Now this one is the easy step for finding the differentiation. Let's go for finding the differentiation with respect to x. Okay. So pi by 2, which is a completely constant term, differentiation of a pi by 2, it goes to 0, minus differentiation of x by 2, which is a minus only 1 minus 1 by 2, which is equal to y of x. Okay. So here I get the value for y of x, which is a minus of 1 by 2. Okay, so the value for y of x is a minus 1 by 2, but we want y of x at a point x which is equal to 5 pi by 6. Okay, at x which is equal to 5 pi by 6, x which is equal to 5 pi by 6. So put x which is equal to 5 pi by 6, but we don't have y of x in the form of yx, so our answer it remain 1 by 2 only. Okay, so our required answer, which is a 1 by 2, given in our option number D here. Okay, so I hope you all have understood. Very easy type of the solutions are these ones. Let's move for the next question. Now next question, it is completely depend on continuity of the function. Okay, when function is continuous, when it is differentiable, when it is continuous, and is there all the statement are true or not. Okay, this is given in our example. Now we can expand first of all the example, what actually we have given in the example. Okay, so we have function modulus of f of x, which is equal to modulus of x minus 3, but for what values function gives us modulus x minus 3? What values when we consider x is 1? Okay, for x is equal to 1, obviously modulus x minus 3 is coming. When we take x which is equal to 2, obviously modulus x minus 3, that means all the value which 1 or bigger than 1, we consider f of x as a modulus x minus 3. Okay, so x which is equal to 1, x which is equal to 2, 3, 4, and so on. All the values for x, we consider f of x as a modulus x minus 3. Okay, and for all the values of x, which is a 0, minus smaller than 1, x strictly less 1 means smaller the value than 1, that means 0, minus 1, minus 2, minus 3, and so on. Okay, 0, minus 1, minus 2, minus 3, minus 4, and so on. Okay, that means whenever we have to show function is continuous or differentiable for some particular point, we have to select only these functions. Okay, so when we have to show function is a continuous or differentiable for 1, 2, 3, 4, so on, we have to consider modulus x minus 3 only. Okay, and now let's go for the part of options. In our option, we have given x is equal to 1, function continuous x which is equal to 1, continuous x differentiable x which is equal to 1, continuous x which is equal to 3. That means we have to deal only the first function for these values. For 1, 2, 3, we have to go for only the first function. Okay, so our f of x given here, modulus of x minus 3 here. Okay, f of x which is given modulus of x minus 3, and the value for x we have here 1, 2, 3. That means let's verify whether function is continuous at point x which is equal to 1 or not. Okay, and now we know that the definition for continuity of the function, if we go through the graphical way, the function which do not have any break or any gap between 2 points, okay, then we say that function is continuous. Or in mathematical way, we write limit, positive limit for our given function, negative limit for our given function, which is equal to f of our constant, then function which is a continuous. Okay, so we have to show for x which is equal to 1, that means we have to show f of positive limit, that means f of 1 plus, which is equal to f of 1 minus, which is equal to f of 1. Okay, if these three conditions hold, then we say that function is a continuous at x which is equal to 1. Okay, now for this function we have f of x is equal to modulus x minus 3. So put all the values, modulus x minus 3, that means 1 minus 3, modulus 1 minus 3 for positive limit, 1 plus of minus 3. Okay, again 1 minus of minus 3 again, and f of 1 minus 3 again. Okay, now see that modulus of minus 2, modulus of minus 2, modulus of minus 2, so which gives us 2 which is equal to 2 which is equal to 2. If this condition hold, then we say that function is continuous at point x which is equal to 1. Okay, so function which is continuous at point x which is equal to 1. So obviously our first option is coming correct. Okay, similarly we have to show the function is a differentiable at x which is equal to 1. There is a relation between continuity and differentiability. Whether the function is continuous, then it implies differentiable, or differentiable implies continuity. Okay, this one the result which is also applicable. Okay, now let's go for the next part. We have to verify whether it is a differentiable for x which is equal to 1 or not. Okay, yes, that means we have to apply limit as a positive h tends to 1 plus positive limit as h tends to 1 minus and h tends to 1 f of x plus h minus f of x upon h, then function it goes always differentiable. Always differentiable. Okay, so function it goes to the differentiable for at point x which is equal to 1. So if you want to verify, you apply limit as h tends to 1 f of x plus h minus f of x upon h. Apply this result, find out the value for positive limit, negative limit, you will get the function differentiable. Okay, so as you can go through the finding the graph. Okay, as you can go through the finding graph of our given function, we can write directly the peak point of our graph. Okay, the peak point of our graph, that means modulus function always gives us the peak point in our x or y axis. Okay, that means when the point for x axis it goes to the origin, or when the point it goes to the y axis, we get the peak point there. Okay, we get the reflection for that image. So if we get the peak point of our graph, so we cannot draw the tangent on that point. Okay, when we have peak point like a V shape, we cannot draw the tangent on that point. So if a tangent not able to plot there, then we say that function not differentiable at that point. Okay, we need a curve. We need a curve to show given function is a differentiable. That means in a curve we can show that our tangent touches to our curve at one and only one point. Okay, then we say that function is differentiable. Okay, that's it for the next option B. Option B coming true here. Let's go for the option C. Function is a continuous at x which is equal to 3. That means same condition we have to apply for this function. X which is equal to 3, that means x which is equal to 3 here, and which goes to the modulus x minus 3. Okay, okay, x which is equal to 3, let's prove it out here. F of 3 plus which is equal to f of 3 minus which is equal to f of 3. Okay, 3 plus means modulus of 3 minus 3. Okay, 3 plus of minus 3 which is equal to modulus of f of 3 minus of minus 3. Okay, okay, 3 minus of minus 3, that means 3 minus of 3 which is equal to 3 minus 3. Now observe that 0 which is equal to 0 which is equal to 0. That means all sides gives us the value 0. That means we say that function is a continuous at point x which is equal to 3 here. Okay, so our option number first A true, option B true, and option C, all of these options are true. Okay, so then we say that all above options are true for our given function. Okay, so I hope you all have understood this solution. Let's move for the next example. So in our next example, we have given function x to the power y which is equal to e to the power x minus y, and we have to find out the value for dy by dx. Okay, so what we want the value for dy by dx using our function. Okay, now see that our option represent function to the power function. Our example represent function to the power function. In this situation, we have to apply logarithmic type of the differentiation. Okay, so simply apply logarithmic differentiation to our function. That means apply log here, apply log here. Okay, so log of x to the power y which is equal to log of e to the power x minus y. Okay, log of x to the power y which is equal to log of e to the power x minus y. Okay, so apply exponent rule for the differentiation. Take y front here, y which is equal to log of x which is equal to x minus y into log of e here, and we know that log of e means log to the base of e which is equal to 1, and log e always gives us the value 1 here. Okay, So this gives us the value 1. So we write y into log of x, which is equal to x minus y here, okay? Y into log x, which is equal to x minus y. So let's go for finding their differentiation. This one is the simplified form for our differentiation. So y log x, which is equal to x minus y. Take the similar term to the one side and remaining term to the other side. We will get the required differentiation, okay? Yes, then we write y, which is equal to, okay? So we take it all the y term together. So it is easier to differentiate the terms, okay? So if we take all the term of y together, okay? Yes. So what we have here, y log x. Take that y to the other side. So we write y log of x plus y log of x plus y, which is equal to x. Take y common from these two terms. Y into log of x plus 1, which is equal to x. Take that part as the denominator. So we write x upon 1 plus log of x here, okay? This one is our required function y, okay? And now we have to differentiate our given function with respect to x here, okay? So as we have u by v form, that means apply the quotient rule for the differentiation. Differentiation of u by v, what it says that u upon v, v into derivative of u minus u into derivative of v upon v square. This one is the quotient rule for the differentiation, okay? So dy by dx can be written as v. V means 1 plus log x, v into derivative of u means dx by dx, okay, v into derivative of u minus u into derivative of v, 1 having differentiation 0, log x having differentiation 1 upon x, upon denominator square, that means 1 plus, it means x as it, 1 plus log x as it, differentiation of x with respect to x, it goes to 1, okay? 1 plus log of x bracket square here, okay? So next step we write here. So dy by dx can be written as, very simple answer is this one, nothing, just need to apply some basic calculations, okay? 1 plus log x dx by dx as it is, 1 plus log of x dx upon dx, that means differentiation of x with respect to x gives us value 1. X into 1 by x gives only minus 1 upon 1 plus log of x bracket square, okay? 1 plus log of x bracket square. So plus 1 minus 1 cancel. So dy by dx can be written as log of x divided by 1 plus log of x bracket square, okay? This one is our required answer, which given in our option number D here, okay? Now see that how easy type of the question are coming in your JEE CET exams, okay? Latest question from your previous year question papers, okay? I hope you all have understood. Let's move for the next example. Okay, this one is the last example for our today's lecture, okay? As we know that this one is the standard form, okay? Y which is equal to cos square of 5x by 2 minus sin square of 5x by 2, which is given function. That means we have given y which is equal to cos square theta minus sin square theta, okay? And as we know that one standard form for cos square theta minus sin square theta as a cos 2 theta, that we will apply here, okay? So cos 2 theta can be written as cos square theta minus sin square theta, okay? Cos square theta minus sin square theta can be written as cos 2 theta, okay? And theta we have here, what is the function given? Y which is equal to cos square of 5x by 2 minus sin square of 5x by 2, okay? That means y which is equal to cos square theta minus sin square theta. We write as the y which is equal to cos of 2 theta, cos of 2 times theta, 5x divided by 2. That 2 cancel with this 2. So y which is equal to cos of 5x, and we want d square y by dx square. That means a differentiation of y twice, okay? 2 times we want the differentiation of our given function. First of all, find out the first differentiation. So we write it as the dy by dx, which is equal to differentiation of a cos of x, which is a minus of sin x, okay? So minus of a sine of 5x, and function it is like a composite type of the differentiation. So differentiate 5x later on also. So differentiation of a 5x, it gives only the 5, okay? So this is the dy by dx, which is a minus 5 sine 5x. We want the d square y by dx square. That means differentiate our function again. D square y by dx square. That means minus 5. Keep it out because this one is a constant term. Sine of 5x having differentiation cos of 5x. Cos of 5x. Okay. Into differentiation of a 5x later on because composite differentiation, which is gives only the 5. Okay. So solve this step later. Minus 5 multiplied by 5, which is a minus of 25 into cos of 5x. Okay. And as we know that cos of 5x can be written as y. So d square y by dx square can be written as minus 25y. This one is our required answer from our given example. Okay. This one is also which is given in our option number C, our C option, which is correct here. Okay. I hope you all have understood everything from this example. Okay. So even after, if you found anything difficult within these examples, let me know in comment section, or if you have any doubt, difficulty, let me know also. I will come up with the new videos. Okay. Now, in our today's video, let's go for little recap what we have learned so far in our today's lecture. Okay. So at the beginning, we started the definition for differentiation that we learned for differentiation of first principle. Subsequently, composite type of the differentiation. We have learned different type of the differentiation like logarithmic differentiation, implicit type of the differentiation. After that, composite function differentiation. Okay. So I hope you all have understood everything from my today's lecture. So if you wanted to see similar videos, you do check in my playlist. You will get the all type of the videos there. I hope everything from our today's lecture you all have understood here. Even if you found anything difficult, let me know in comment section. I will come up with the new videos. So thank you everyone. Thank you for my today's lecture.